Good afternoon. This is Kavipriya, Assistant Professor, EC Department. So we're going to discuss about the topic bridges. So bridges are of two types, AC and DC. So under DC we have a wheatstone bridge. So in today's session we're going to discuss about this bridges, types of bridges, and we're going to discuss about the wheatstone bridge, which is a type of a DC bridge. So first, what is a bridge? So bridges, if electrical components are arranged in a form of a ring structure or in a form of a bridge, then the electrical circuit we call it as a bridge. In general, bridges forms a loop, the set of four arms or branches. Each branch will contain one or two electrical components. There are two types of bridges. First one is a DC and second one is a AC. DC bridge is used for measuring the resistance. AC bridges is used for measuring the impedance. It consists of capacitance and inductance. DC bridges uses a DC voltages as a excitation voltage, while AC bridges uses a alternating voltage as a excitation voltage. There are two type of DC bridges, which is a Wheatstone bridge and Kelvin bridge. Under the AC bridge, we have capacitance comparison bridge, inductance comparison bridge, Maxwell, Hay, Henderson, Sharing and Wayne bridge. So first, what is this DC bridge? If a bridge circuit can be operated with the DC voltage signal, then it is called as a DC bridge circuit or simply a DC bridge. DC bridges are used to measure the value of the unknown resistance. And this is a circuit diagram of DC bridge. Here we'll be having a four branches and resistance is connected. One or two components can be connected in each branch. Here we have one component. Each and every branch has one resistance, and the supply will be given to any two junction point, and other two junction points is get connected with the galvanometer. Galvanometer is used to indicate the current that flows in the particular bridge. The above DC bridge has a 4 amps and each amp has a resistor, and two resistors will be having a fixed values, and one is a variable and other one is the unknown resistor. The above DC bridge can be excited with the help of a DC voltage source by placing it in the one diagonal. Galvanometer will be placed in the other diagonal. It shows a deflection as long as the bridge is unbalanced. So when a bridge is balanced, the galvanometer shows a null deflection. So when bridges get balanced, when galvanometer shows a null deflection and will be calculating a value of an unknown resistance. Under AC bridge, if the bridge circuit can be operated using the AC voltage, then we call it as a AC bridge or simply AC bridge circuit or simply AC bridge. AC bridges are used to measure the value of unknown inductance, capacitance, and also it is used for measuring the frequency. This is a circuit diagram of the AC bridge. It has a impedance, 4 impedance, and we have a detector or galvanometer and will be having a supply. The circuit diagram is similar to that of the DC bridge. The AC bridge also has a 4 amps and each amp consists of some impedance. Each arm will be having either a single or combination of passive elements such as resistor, inductor and capacitor. Among the four impedance, two impedance will be having a fixed value, one impedance is variable and another one is the unknown impedance. The above AC bridge circuits can be excited with the AC voltage source by placing it in one diagonal, and detector is placed in other diagonal of the AC bridge. It shows some deflection as long as the bridge is unbalanced. The above AC bridge circuit can be excited with the AC voltage supply. A detector is placed in the other part. So when a detector shows a null deflection, we can measure the unknown impedance. And a Wheatstone bridge is a type of a DC bridge. So Wheatstone bridge is also known as a resistance bridge. It calculates the unknown resistance by balancing the two legs of the bridge circuit. One leg includes a component of unknown resistance and one leg consists of a components of known resistor. So it consists of two known resistor, one unknown resistor and one variable resistor. All the components will be connected in a form of a bridges. So this bridge is very reliable and it gives accurate measurements. Construction wise, Wheatstone bridges consist of 4 branches and each branch resistance is get connected, and to the two junction points supply will be connected, to the other two junction points a galvanometer is being get connected. So under this four resistance, two known resistance will be there, one is the unknown resistance and one is a variable resistance. As long as the bridge is unbalanced, current will get flows through the galvanometer, and once the bridges get balanced, we can there will be a null deflection in the galvanometer, and we can find the value of the unknown resistance. So the current that enters a galvanometer is divided into two equal magnitudes, that is nothing but I1 and I2. So the following condition will be exist when current through galvanometer is 0. First one is I1P should be equal to I2R. So the current in the bridges is in balance condition. So we know that I1 is equal to I3, which is nothing but voltage divided by resistance. So E by P plus Q. Here the voltage is represented as capital E. I2 is equal to I4 is nothing but E by R plus S, where E is the EMF of the battery. By substituting the values in the equation, we will be getting this P by P1 P plus Q and RE by R plus S. On simplifying the equation, we will be getting this R unknown resistance value is nothing but P by Q into S. So this P, Q and S are known resistance and the variable resistance. R is the unknown resistance. So the value of unknown resistance is being obtained, and also we have obtained the bridge condition also. When PS is equal to RQ, the bridge is said to be in balance condition, which means that no current will flows to the galvanometer. So the resistance of the opposite branches should be equal. Application and limitation. It has application. Wheatstone bridge is used for precise measurement of low resistance, and it is used in amplifiers, operational amplifiers. It is used to measure the physical parameters such as temperature, light and strain, and quantities like impedance, inductance and capacitance can be measured using this variation on the Wheatstone bridge. Limitation is that for low resistance measurement, resistance of leads and contact becomes significant, and there is a chance for reduction of errors. For high resistance measurement, the measurement pressure presented by the bridges is so large, the galvanometer is insensitive to imbalance. The other drawback is that resistance change due to current eating effect through the resistance. Excessive current may even cause a permanent change in the value of the resistance. So that's all about the general introduction to bridges, types of bridges, and we have seen about this Wheatstone bridge, which is a type of a DC bridge. Thank you.